In the last video, we used if statements to compare two integers, and we also used if statements to compare two strings. Well, taking this one step further, we can use an if statement to compare a Boolean value. You remember that a Boolean value is either true or false, and we can say if some Boolean value, like game over, equals true. Remember, this is the equality operator here. We're comparing for equality. This is an assignment operator. It sets something as to something else. We're setting the game over to true or false. This is an equality. This is for testing. Is game over true? And if it is, we'll say game is over. And if it's not, say the game is not over. I think this is very straightforward. I don't think there's anything tricky about this. It simply says the game is over because it is. Set to true. If we change this to false, then we can say the game is not over. Now, changing this back to true for a moment, one important thing to understand here is that equals true is not necessary in almost any modern programming language. In almost any modern programming language, is true is implied with just this. Now, a beginner looks at this and says, this is confusing. If game over what? If game over is blue, is red, what is, is equal to 3, equal to 4? I don't know what, I don't know what to say. Well, you look and see what type of variable are we dealing with. It's a Boolean. So we know if game over means, is it true or false? So if we run this just to prove it, it says the exact same thing. It's true, so it prints true. If it's false, it prints game is not over. Let's run it, and that's what it means. So we can take this for a moment, and we can just actually let me change this back to true. Whoops. Let's take and comment this out. And let's look next at our if and else statements. Remember, well, here's an example here, if and else. But we can take this one step further. And let's give us kind of an example to work with maybe. Let's say we have price is equal to 50. And let's say if price is less than 100, print your discount is 5%. I don't know. Yeah, 5% sounds good. And let's just take and paste this on down a few times to give us some variation. Let's say, make this 300 maybe, 500, 800. Change this from 5%, 10%, 15%, and maybe 20%. Something like that. So if we run this, what do you think is going to print here? We have a price of 50. And what we're wanting to say, if maybe in this example, is if the price of a total bill of sale is a certain price or below a certain price, then some sort of discount is applied to the bill, right? I think that's sort of the accounting idea of what's happening here. If we run this, we don't really quite get the output that we expected. We really just need one discount. We don't need 4 different discounts printing, do we? And there's other ways we could arrange this to solve this problem, but there is also a programming construct we can use, and that's called else if. You've learned about if, you've learned about else, but now there's something called else if. It's abbreviated in Python as elif, or else if, a combination of the two words. Else, el, the sc is dropped, and we just have else if, or elif. So if we run this, what's really happening here, this is very important that you understand. What's really happening is once any of these statements are true, Python does not even check the rest. So if this first statement is true, if price is less than 100, this prints, and the rest of these statements are skipped entirely. Python doesn't even look to see if price is less than 300. So it's not even evaluated. This is never evaluated. This is never evaluated. This is never evaluated. Why? Because this was true. What if we say 150? Let's run this. This is false. So then Python says, okay, let's go to the next one and see if that's true. And this one is true. Is the price less than 300? Yes, 150 is less than 300. So this prints. But again, remember, in an if-else-if chain like this, these are considered chained together because they can't be standalone statements. If can be standalone, but not these else-ifs. And I'll take a look at that and show you that in just a moment. But when we have a chain like this, once the first one is true, in this case it's this one, once this condition is true, this executes, nothing else does. That's the power of else if. You use it when you need to only, I guess it makes the most sense to use it when once something has been chosen, there's no need in comparing anything else because it just doesn't make any sense. Kind of like in a menu program, if you were expecting output from A to Z. Well, if the user chose A and that's your first comparison, then why are you looking any further? It doesn't make any sense, right? And here it just flat out introduces a bug when we don't use else if because we had multiple discounts printing, which doesn't make any sense. Interestingly, I think I alluded to it a moment ago, these aren't standalone statements. You can't just say else if out of nowhere. You can do if, we can say if, that makes sense. But we can't just say else if by itself. Now, one common question is, well, can we do else on the back end of this? Can we tack on else? And yeah, you can. You can. I'm not sure it makes a lot of sense here, but you can, else is again a catch-all. If anything else is out there that is above, let's see, above 800, actually 800 or above, then else is going to print. And maybe we can just say, I'm not sure this makes a lot of business sense, but we're not really looking at actual accounting here anyway. Just need something to give us a working example. And so yes, you can tack on an else, and just to be clear, in case it wasn't, else is not a standalone statement either. It doesn't make any sense. So you can chain, this is called a chain of if, else, and else. And yes, you can chain them all together. This gives you quite a bit of power and quite a bit of functionality. There was a time in computer science where processing cycles and memory was so precious that if you're running a menu-based program, that you didn't, once you found a match for something, or maybe even if you were running this code here, once you found the match, you didn't want to waste processor time by searching every other one of these because you've already found a match. If you're sure you can only have one match, or you only need one match, then it makes sense to use else if. These are another way of looking at this, another way of saying it is these are mutually exclusive. Once any of these conditions is true, this one, this one, this one, or this one, the program doesn't even check the rest. If this hits, the program doesn't look at the rest of these. If this one is true, the program doesn't look at the rest of these. And if we take these back off, you can remember how the bug that was introduced and why we needed to do it to begin with. And now let's look at something else. Let's take and comment this out real quick. Let's look at the issue of the book refers to logical operators, section 3.5. Now, logical operators include, these are easy, and, or, and not. These are easier to type in than the relational operators, which in the previous video I didn't even try to type those in. There were so many of them, I just had to refer you to the table. Let's say we have just a quick example here, give you a flavor of how this works. Let's say high income is false. This is a Boolean variable. Good credit is true. So you don't have high income. You do have good credit. We'll change these around here in a minute. But if high income and good credit, let's go ahead and change this to true. Then we might say you're eligible, else not eligible. Now remember what we talked about up here about game over. The equals true is implied out to the right. So this is the same as saying this, right? So that's what we're saying here. We're saying if high income is true and good credit is true. Another way of reading that is if you have high income and you have good credit, you're eligible for this loan, right? Let's say it's a loan. Python doesn't know or care if it's about a loan, but just for English clarity, let's say we're talking about a loan here. So this is kind of interesting. You can use and, or, not. So if we ran this right now, what would happen? We're eligible, right? Now if we change, let's say we've got good credit, but we don't have high income, whatever that even means, right? But let's just see. Well, now we're not eligible because and means they both have to be true. I think that's fairly clear. What may not be as clear though is or. Now or means only one side or the other side has to be true. So we either need high income or good credit. Remember, and means both have to be true. Or means one or the other. So now if we run it, what's going to happen? We weren't eligible before, but hey, we are now. Because one of these is true. And we only need one for or. Let's try this though. If they're both false, it should be obvious what happens. You're not eligible for the loan. You needed one for or. You didn't, and you had 0. They both were false. Obviously, this is false because and requires 2, and you don't even have 1. So you're nowhere close to being eligible for the loan. Now, one thing we could do, we could throw in another variable here just for fun. We could say student is false. So now we're going to factor into this equation whether you are a student. So let's see, maybe change this to true and this to or. Let's just get rid of this here. And now this is interesting. We haven't used parentheses in a while in these videos. Parentheses refer to order of operations. We're asking Python to do this comparison first, just like in math. If you remember in maybe pre-algebra, or even before that in elementary school, when you use parentheses, you're telling the reader, hey, do this first, whatever's in parentheses first. Well, the same thing applies here. Whatever's in parentheses is evaluated first. So we're wanting to compare these two, not good credit and not student over here. That's confusing anyway. We'll get to that in a minute. So the result of this comparison is high income or good credit. We need one or the other. And is that true? Is this overall true right here? And remember, we only need one of these to be true for the whole expression, the part in parentheses, to be true. And the answer is yeah. I mean, yeah, we have a true statement here, the way this is written right now, because good credit is true, and that's good enough. And then we're saying not student. So what are we really saying there? We're saying student is false. That's another way of stating student is false. And as confusing as this might get, Boolean logical operators, this can get a little confusing. And this is really as deep as we're going to go in this course, so don't worry. It doesn't get any harder than this in this course. And I'm not even sure any of this is really on an assignment anyway. But just so you know, this statement here is actually true. It's true that student is false. And if that's confusing, well, welcome to computer science. But so what we have overall are two true statements. Therefore, the if condition is satisfied, and it should print eligible for the loan. Now, if we say true for student, this will fail. Because remember, this is evaluated first, and that's how we get the true. But then and remember, do you remember what and requires? It requires both sides of the equation to be true. And here it's not true, is it? Because student, it is true that a student, that this applicant is a student, but we said not student. When we say not student, we mean it flips it around. We require them not to be a student, but they are students, see? And we can keep adjusting and playing around with this. If we take away not, now what happens? Now it's true. Why is it true? Because student is true. We need high income or good credit, true. And we want them to be a student. May not be good business sense to base a loan on this, but in this example, we want them to be a student, and so it's true. Maybe this is a student-only loan. So I hope you can see this. Now it's going to print eligible again. But this is how you can chain together logic using an if statement. It shows you an example of how to use parentheses to control the flow of logic, or at least, yeah, to make it look more, and to make it more readable as well. It's always good to use parentheses like this.